I'll share with you the screen here. Okay, so in this chapter, CHF4203, week 7. Did you find it? Under what? Week 7 or 6?
Week 6.
6, 7, yeah, both weeks. 2 weeks combined. Okay, so in this chapter, we will discuss point-to-point connections. We'll learn about PPP, what are the authentication options, how it works. First of all, we need to understand the demarcation point. What is demarcation point by definition? Walaikum salam. By definition, it marks the point where your network interfaces with a network that is owned by another organization. And let's say by the ISP. So where is the borderline between your network and the ISP? Okay. Interface between CPE, who are customer premises equipment, and network service provider network. All right. Also, it is a point in the network where the responsibility of the service provider ends. Okay. If you call Etisalat, they will tell you, oh, it's not our responsibility because after the demarcation, it's your responsibility. All right. So here we have in the United States, it is here. And the international, it is here. All right. Okay, any questions about this?
Is it like a device? Or...
Yeah, there is a device, yeah, they put there. Okay, when you get the connection, the one connection, they will tell you. After this point, after this device, it's your responsibility. Before is our responsibility. Okay. CSU, DSU, it is Channel Service Unit Data Service. CSU يعني Channel Service Unit, DSU يعني Data Service Unit, is a digital interface device used to connect DTE to a digital circuit line. This is all for serial connection, for WAN connections. We don't use this inside our LAN here. Okay. DTE, DCE always coming. What is DCE and what is DTE? So you have to know them, please. So DTE, commonly CPE, customer premises equipment, and generally like router, terminal, computer, printer, these are all DTEs. Okay, so it's a customer premises equipment. DCE, data communication equipment, like a modem or CSU/DSU. It is a device used to convert the user data from the DTE into a form acceptable to the WAN. Got it? This is where you connect to the WAN. The signal is received in the remote DCE, which decodes the signal back into a sequence of bits. So here we have DTE, DCE connection. DTE, DCE, DCE, DTE. DTE is the router. DTE is the router. Here. This is the cables for serial connection. These are serial WAN connection cables that are used in the lab. Okay. So here we have two LANs. They are connected with a serial cable. One side will be DCE, the other side will be DTE. Otherwise, it will not work. DCE, this is where the clock rate is set. Please remember this. DCE, where you have the clock rate. DTE, you don't set up clock rate. DTE will take the clock rate from DCE device. One encapsulation protocols, DTE is encapsulated into frames before crossing the WAN link. So an appropriate data link layer 2 must be configured for WAN to work. These are example of the protocols, of the encapsulation protocols. We have PPP, HDLC, SLIP. So these are all leased line on top. These are leased line. Then we have circuit switched, okay, such as HDLC, PPP, and SLIP. And we have packet switch such as frame relay, X.25, and ATMs. We will do a lab on frame relay. We did already a lab on PPP. We will do a lab on frame relay, maybe next class, inshallah. HDLC, it's a high-level data link control, is a group of protocols or rules for transmitting data between network points. That's the HDLC. SLIP is serial link internet protocol. Okay, but this is an old protocol. It's obsolete now. Very slow. We have PPP. Is a much more developed protocol than SLIP, and it replaced it. Then we have frame relay and ATM. It is used in today's enterprise WAN networks, such as frame relay, ATM, and legacy X.25. X25 also is old now. Nobody is using it. Let's talk back again about HDLC encapsulation. It is bit-oriented and synchronous data link layer protocol, and it's developed by ISO. So it's open standard. Uses synchronous serial transmission to provide error-free communication between 2 points. It is a layer 2 framing structure, so it depends on layer 2. Layer 2 here, which layer? Network access layer. What's layer 1? Physical. Good. Now Cisco has developed their own HDLC, so it's proprietary of Cisco, and it is called Cisco HDLC or CHDLC. CHDLC is proprietary, only works on Cisco devices. To configure HDLC encapsulation, you will call the interface and then you give the command encapsulation HDLC. Okay? PPP, point-to-point protocol. It has 3 main components. HDLC for encapsulation. And then we have Extensible Link Control Protocol, LCP, to establish, configure, and test the data link connection. And then we have Family of Network Control Protocols, NCP, to establish and configure different network layer protocols, IP version 4, IP version 6, AppleTalk, Novel IPX, and SNA control. But now most popular is IP version 4 and 6. So these are the components of PPP. What are the advantages of PPP? First of all, it is not proprietary, open standard. And it has many features that are not available in HDLC, such as link quality management feature. It monitors the quality of the link. If too many errors are detected, PPP takes down the link. Okay? It supports PAP and CHAP. We already mentioned this yesterday, on Monday. On last week, previous class, right?
Yes. Monday.
Yeah, Monday, I think. Yeah, for your class Monday, yes.
Just to make sure.
CHAP is the secure one. Okay. Here we have the PPP layered architecture. Here we have the PP layered architecture. We have LCP. Remember we talked about LCP here. Sorry. Yeah, we talked about LCP, NCP, and we need to know where they sit. Yani where are they? Top, down. So in this diagram, you can see here, this is the physical layer. Here you have synchronous or asynchronous. And then here you can find, you have your PPP, and NCP is on top, and LCP is on bottom. خلاص? So NCP is more close to the network layer. Got it? LCP provides automatic configuration of the interface at each end, such as handling varying limits on packet size, detecting common misconfiguration errors, all right? Terminating the link because it's close to the physical layer. But if you come to the NCP, NCP is close to the network layer. Sorry. Let us continue with LCP functions. LCP is responsible also. Optional functions also are PAP and CHAP. Compression also. Compression can be done using stacker or predictor. Unfortunately, we are not going to do lab on compression, but we have already done lab on PAP and CHAP. Multi-link also, that combines 2 or more channels to increase the WAN bandwidth. All can be done in PPP. Okay. This is multi-link. You see how many senders can send on using the same link. To configure PPP, like we did in the lab, for authentication, we have 2 options, PAP and CHAP. For compression, we can use stacker or predictor. So it is compressed at the sender and decompressed at the receiver. The configuration is like we did. You go enable config terminal, you call the interface, and then what's the command? Encapsulation PPP, and then you do the authentication PPP authentication PAP or CHAP, and then you can check. All right, any questions? No. Because this is coming in the practical. No? To verify connection, to test the connection, we can use show interfaces or show interfaces serial or show PPP multi-link. You have to know these commands, okay? This is how you check your PPP to verify that PPP is configured properly. So you see when you do show interfaces serial, it will show you the statistics of the serial as 0/0/0. See here, line protocol is up. You can see here encapsulation PPP, LCP is open, all good, life is good, okay? Here we try to learn more about PPP and CHAP and PAP, okay? The authentication, we have PAP, two-way authentication, two-way handshake, username R1, password Cisco123, all in text. Okay, so R1 send this information, R3 will accept or deny. That's it. So it's not secure. CHAP uses three-way handshake. And the central router, the headquarter, will send the challenge. Not the user, not the end user, not the remote. That's why it's more secure. And it will send a hash. Okay? The remote router will send a hash, not a text password. And that's it, accept or reject.
So CHAP is more secure than PAP, right?
Yes, of course. We mentioned it. Remember? Okay. Any other questions?
No.
Initiating PAP. Here we have. This is also just description how it is working. R1 sends its PAP username and password to R3. R3 evaluates R1 username and passwords against its local database. If it is stored, if it matches, oh, okay, you are good. I have your information. Come. Okay. This is how it is done. CHAP, no. CHAP is the head central will send the challenge question, and the remote router will send the answer with hash information. These are the configuration options. Please have a look at them. We have CHAP, PAP, CHAP, PAP. You can have together, but CHAP will be performed before PAP. Here, PAP will be performed before CHAP. Okay. Here we have other statistics. Okay, if needed, they can use TACACS or XTACACS and other security. If you are to go do more deep into networking, you will learn about also using these protocols. All right. Any questions?
No.
To configure PPP authentication, I have already mentioned that. Here we have on router 1 and on router 3, router 2. Okay. To configure CHAP also, this is the main command, PPP authentication CHAP. Okay? Very good. Any questions? I'll start.